Hey everyone, today we'll make a delay that sounds like this. Okay, enough of that. I already wasted so much time playing around with this. As you see, there are two knobs for the rate control, which is just like a numerator and a denumerator, a retune knob which determines how fast it should move from one rate to another, and a feedback knob for, well, applying feedback to the feedback delay. So let's just get started, I guess. But first of all, I wanna open the script on my other screen, so when I'm getting out of ideas, I can just look at it, so I don't have to waste your time. Obviously my videos are long enough. By the way, I'm always procrastinating from doing stuff for university by doing these videos, and I'm also procrastinating from working on my other programming projects for these videos. But it's a lot of fun because I want to enable you to see more about the world of programming and my world and my interpretation of this world as well. Also, if you are a juice person, then I want you to see that PNS is actually really powerful. And if you are a PNS person, then I want to show you that PNS is cool, even though I am a juice person as well. And we don't have to be enemies or something, because sometimes I see this discussion from the juice side. There are people who say that that PNS is for noobs, and from the PNS side I see people who claim that they are not ready for C++ yet and it's all too complicated for them and stuff. But it's not right. It's actually very similar and you can just do both, and they all have their use cases. So we will make this delay in this video, and in my next video I will use this project or the project that will result from this video to make a point about PNS and juice, because I will then recreate this project in juice, and then we will compare what are the benefits and what are the disadvantages of each approach, and then you will see that it actually makes a difference, that you can just write the scripts here in PNS and don't have to write them in juice, even though you might want to make your final projects in juice. But we will discuss that in the next video, just so you know that what my plans are. Well, let's start. Okay, so now we make a new project. What's our date? It's this date, and we'll make another delay. Oh, oops, yeah, obviously, no. Oh man, I have to give it a new name. Okay then. All right. Okay, so well, what do we need for a delay? Well, first of all, let's I already know that we have to use this function differently later. So let me just rewrite it like this, so that it doesn't return an int, but actually a double value that still behaves like the function would usually behave. Cool. So just that we have the default function, the default script ready for everything and stuff. Okay, so now let's make a new script. And we use my namespace again. By the way, if you are a newcomer or new to programming in general and ask yourself what's this all about, then let me just tell you, you don't have to use a namespace. And actually this only makes sense if you have other namespaces as well. And I just do that for fun because I'm HDL Audio and this is my namespace, you know, but you don't have to do that. Okay, so yeah, let's just save it, a new header file, and we will include it now. Cool, now we have access to everything that is in this file. We want to make a delay, and first of all we make the simplest kind of delay, a feed-forward delay. Now what do we need? We need a buffer with data. And obviously we need a method that returns the size of that buffer. So we don't always have to write data point length, but we can just at any point now write size when we want the size. Okay, cool. Now that we have that, we can initialize the class. And I would suggest that we give it a default value, the maximum size of the buffer equals, you know, sample rate is 1 second. So when we multiply that with 5, then we have 5 seconds of audio, and that should be sufficient. Maybe it's even too much, because you don't need the delay for the whole. You know, when I started to think of delays, I thought you would have to give a buffer the size for the whole time it repeats, but this is actually just describing one repetition. Okay, just so you know that. So the first thing that we have to do is length is max size. Cool, now that we have that, we need an index, a write index that will write to our buffer. And then we also need a process method, and it will also return a value, obviously. This is our input sample, and at some point it will create an output sample and return that sample. And I just write 0 for now so that everything works. So this would return 0 now, or actually let it just return X, so nothing changes about the sample when I do that now. That's pretty boring. Obviously we want something to change. So we want to have a function set delay in what do we do? In seconds. Yeah, let's just make it in seconds for now. And we have to give it a delay. So now obviously we have to put it inside of here somewhere. So we have to have a delay, and obviously it must be double, since we are giving it a double here. And yeah, if you set the delay in seconds, then you can't just do this, because maybe if this is 1 for 1 second, then it would only make sense if we multiply that with sample rate again. And now this actually contains the amount of samples to resemble this delay in seconds. Yeah. Okay, so now what we can do is for each process, for each sample, we will write data into our buffer at our current index. By the way, we have to give the index a default value of 0 so that it doesn't start out of bounds for some reason. I know integers and uints are default values at 0 by default in AngelScript, but when you go on to other languages later, you will see that this is actually undefined behavior. Okay, so now we have no y value left, actually we need to find out at which index our delay is. So we call this the R index, and we define that as current write index minus delay. Now this could very well be below 0, so we have to bring it back. If it's below 0, then we will we will put it up by the size, so it pops up on the other side of the array again. And then we will have a function get sample, and it will return, actually let's just put that in one line because it's very short, data at R index. Obviously R index now needs to be a member variable for that to work. So cool. So now we can just define y as get sample, and obviously this needs to be round to int because a double value can't be accessing an array. And yeah, I know we could do interpolation here, but you have seen in my last video, if you watched my last video, how we can use inheritance to get an interpolated sample from this method. And for this video I will just skip that because the delay that you heard before also had no interpolation and it still sounded nice, so why not? Obviously we still have to do something here because the write index has to move on. After all the index stuff has been calculated, we have to let our read index move on. And we're doing that by creating a new function, calling it increment, because it's meant to increment stuff. It increments our write index, and if the write index reaches size, or actually we can be more precise here, if it just is size, then our write index equals 0. This will be sufficient. Also, if you want to use inheritance, it makes sense to use protected instead of private. That's something that I forgot to say in my last video. If you used private here, then you cannot access it in the next layer of inheritance, so to say. But you would still want this to be protected because then it can't be accessed from the main method or something. So this is a very nice way to describe how this method should be used by the developer who's using the function. And all the other methods can just be used from the function, from any point of the code. So that's cool. So let's see if we have forgotten something. This should work very well. Let's put that into one line so we have a better overview over everything. Yeah, okay. These functions also belong together. So now we can see the whole class in just one window. Let me see if everything works here in my stream. Yeah, looks fine. So now let's load that. It seems to work, but we have no controls yet, obviously. So let us just make an object of the delay. HDL feed forward delay. And now, for now, I will just leave it monophonic. And in order to do that, I will declare a mid value. And now it will just get all the samples in it. And then we will divide through the amount of outputs. so that it doesn't get too loud if it's stereo. Now we have to go through the stuff again. Oh, not yet. First of all, we have to say mid equals delay process mid. So now the delay process is mid and then overrides what is in mid, and then we put that into our samples. So the resulting sound is a monophonic version of the incoming sound with a delay, and we will not just replace it, but we will actually add it so that we hear the delay and the current sample at the same time, and can therefore better hear how far it is off from our sample. And now we have a delay parameter that we can just at each start of the block maybe just say delay set delay in seconds. Did I write that with OU? I think. And it will be this. And how long are we making this? We have a maximum size of 5 seconds, so we can just use this size, but I won't go up to the complete size just in case it doesn't work with the bounds for some reason. You know how that sometimes is. Yeah, it seems to work very nicely. This is a normal feed-forward delay that does not have any feedback. It just delays the signal. You need something like this, for example, when you make a reverb and you make the pre-delay. The pre-delay is usually not a feedback delay, except in the new reverb from Native Instruments called RAUM that you have probably seen. There the pre-delay is actually a feedback delay, which is the reason why it's a comp filter, by the way. Oh, while we're at it, let me show you something, but first of all I will drink a bit. Ah, nice. I will show you something very interesting now. What happens if we take a very small range? And what happens if we take an even smaller range? Hello? Okay. As you've heard, flanging. So this is how you make a flanger. And now let's get back to business. We want to make a real delay. That sounds like a delay. Okay, so now. Yeah, first of all, let's get rid of this mono setup because we want to have it stereo. So what we can do about that, because we can't have arrays of custom objects, is have two objects that are just called like that or something. And then instead of doing all this, we only keep this part. Oh no, we don't even use this. We just say data samples at, oh, I should have left the brackets. I just, oh, did I? No. Channel 0 at sample equals delay left process, same thing. Okay, now we can override the left channel, and now we can say if audio outputs outputs count is not 1, which would mean it's stereo or anything else, but I only care about mono and stereo. I mean, who creates music in surround? I don't, so I don't care. That's just a little joke. If you are a big tech company and you think that I'm that stupid, no, I'm not. I'm just making jokes. However, if we have stereo, then this also. Okay, cool. Now, obviously we have to do this for both delays now, and it will probably work now. No, I made a little mistake. S, it doesn't like the S, Y. Samples, S exists, why not? Oh, of course. Obviously. Cool. No, there is a mistake. I already have an idea what it is. Yes, I accidentally used delay R L again, which is very clicky. Yeah, very nice. As you have heard, when I change the rate, it just goes to the new rate immediately, skips a lot of samples. It just does what we tell it to do, and that obviously doesn't sound nice. It should move over to the new place nicely. And what we can do about that is actually saying our index has a default value, and we add a new value. We call it Retune Speed, and we give it just some value at the beginning, Retune Speed. And from experimentation, I already found out that this value has to be pretty small. Let me just quickly look which value I have on my other code as a default value, so we instantly have something to work with. Oh yeah, right, I remember. When you make a default speed, you want to use the sample rate in it, so that it's the same for all sample rates. Doesn't have to be exactly 4 here, but that's just some value that I came up with. Okay, now that we have that, we can just work with that. Also, we need a delay index. Let me just look pretty quickly at my implementation to see why we need that. Oh yeah, right, I remember. Cool. So now delay index and R index will be initialized to 0. Okay, so now what is the difference? The difference that instead of just directly saying R index where it's supposed to be, we make a D index, and D stands for destination in this case. So the destination index oh wait, no. The destination index is actually following the signal. So we use the retune speed to mix the current value from the destination index with our delay minus D index. And now this is a little bit closer to our delay. Yeah, I remember the logic of this. You know, the buffer usually goes in circles. It's a circular buffer. And the idea about D index is that it doesn't follow the circular motion. Just as the value delay, which is just a set value that just describes how far something is away from W index, D index also just describes exactly that. But the difference is that it follows the delay instead of always being at the delay. And it follows the delay at retune speed. Now that we have that, we can just say the right index is not minus delay, but minus D index. Yeah. And this will just stay exactly the same. And the only difference now is this little thing. And this should already work. can create very nice scratches. Maybe the speed is still a little bit slow. It seems kind of laggy sometimes. I think I would have to turn this down to make it faster. No, actually it must be the other way around. Let's turn it up. Cool now, and if you made it very fast, then you would hear the clicky noises again, and you just have to see what you like most. I mean, it still sounds cool, but it's kind of very laser, and you would expect something like this in an effect that has a granular flavor to it and not a normal delay, I guess. So let's go a little bit slower again. Yeah, I go even lower again, back to 8. I think that's okay for now. We will make a nice retune speed parameter later. So now the next thing that we want to do is actually adding a feedback component. So in order to do that, we just use inheritance again. We make a feedback delay now, and it inherits from our feed forward delay. But now, instead of being like this, we have to override the process method to work differently. And also we have to add a new variable called feedback. And a function set feedback, double feedback. And we have to make a new constructor which gives the feedback a default value just in case that we don't implement this function for some reason. Maybe something like this. Now we also have to call the other constructor from the old class, so to say, and we do that by writing super, and we can actually pass an argument there. So if we were to use max size again and again do this or anything else, then we can just pass it on, and then it will do all this stuff. Okay, cool. So now that we have that working, we can actually implement the feedback. I will just leave this for now. We will use that very soon. So now we have the delay on the second parameter and the feedback on the third one. And let's make some variables for that, delay and feedback. And both of them have some default values that make no sense, just in case that it's getting complicated. Now let's make a function for the parameters. As always, I like to write this function myself. Set parameters, and we will call this function at the beginning to make it a little bit less crowdy in the main method, in the process block. I just like to call it main because it's so important. So now what will happen here is we say delay equals input parameters 0. And yeah, right. I was just checking out my other code to see if everything is cool. This needs to be 1, by the way. As we added a new empty parameter. I don't know if it works to just give it no name. Maybe I just give it a standard name. Now we have to add the feedback. Set feedback. And also for delay R. Obviously we have to make it a feedback delay for this to work. And yeah, I think that should be it for now. Now every time a new block starts, we give it new values. And now we just have to make sure that this is actually a feedback delay and not a feed forward delay. And therefore, what I did was I typed in feedback delay in Google. Actually, I think I wrote it out. And then I went to the image section and I looked at some block diagram. What? I just leave it on Google Images, I guess. And then you can just follow it and try to recreate what you see in the diagram. So let's see what we see there. We see just right at the beginning a sample comes in, but at the same time a sample from the delay comes out with the feedback. So we have some kind of value, and it is the input signal plus a delayed version of the signal. So data actually get sample, is it? And times feedback. Now at this point we don't know what get sample is yet because we didn't do the indexing stuff yet. So let us just take all that stuff and put it above. And also let's just get rid of everything else so that we don't lose the idea what is happening here. So double Y is input signal plus our delayed signal times feedback. Now we are here and the delay must happen. It must save a new value, which means that I know these block diagrams can be a little bit cryptic from a developer point of view, but it basically just means that whatever was here is being put into the delay, which is Y in this case. And now we go out of here, and this is a dry signal, it doesn't matter for us, and then we just put it out. And I think that should be it. Yeah. Okay, so let's test that. Okay, it seems that I must have forgotten something important here, because it does not even play anything. Delay L, delay R, delay feedback, set parameters at each start, input parameters 1 and 2. Not really sure what's the problem here. Oh, right. I don't increment. Okay. Yeah, nice, very robotic. By the way, I did that by holding shift and mouse wheel, so I could actually make such subtle changes down here. You didn't see that on my mouse movements. Okay, cool. Now we have a feedback delay and a feed forward delay, and we can just go on now with the actual Temposync features, because we want this to be Temposync. So we have to write some kind of a rate handler. I called it a rate handler in my other script. So let's just do that now. So our rate handler has a function that processes something. It gets the beats per minute. It gets a numerator, and it gets an denominator. And it will return false usually, but there is also a case in which it will return true, which is it has, first of all, it has member variables. It has a BPM, an X rate, and a Y rate, and a rate. And you will see soon what it means. It means that every time the BPM of the project changes, because maybe the producer made a tempo automation or something, then it will see that it changes. Or when the user changes the rate, which means X is not X rate, or Y is not Y rate. So if anything of this changed, then we will do stuff and return true. So this actually returns if the method was successful. And you will see why this matters later. So first of all, we put the BPM in there. We put the X rate into X, X into X rate, and Y rate into Y. So now we already put our values where they belong. Now we have to make some calculations. BPM equals beats per minute. So obviously we want to go back to beats per second. And we do that by dividing our BPM by 60. Because we have 60 seconds, obviously. But what's a beat? A beat is 1 quarter note. Wouldn't it be much more usable, this method, if this was bars per second? In that case, we have to do this, because we have 4 quarter notes. And what is this? 60, 120, 240. So we can make this easier for our program, but a little bit less easy to read because you don't know what's 2040, where does that come from, but I just told you, so it's cool. Double bar. Now, what's one bar in samples? Easy, it's just sample rate divided by bars per second. Now we have a representation of the length of in samples of 1 bar. And then we can just calculate the rate by saying bar times X divided by Y. Okay, cool. We could have used X rate and Y rate here, because they are the member variables. Maybe that makes more sense, or it's just more beautiful. And then we return true. Obviously, when we want to use this rate in our delay, we have to add a function that will be able to give it back. So get rate, return rate. So now our delay can just get the value from our rate handler. And I think that's already everything that needs to be here. Let me check out my other implementation really quickly if I forgot anything. No, it looks pretty fine. Cool. So now we have the rate handler ready. Where do we get the rate from? Well, I mean, we have to give it the BPM. So we just say data transport get BPM. By the way, if you are asking yourself, what the fuck, how do I find stuff like that? Then you need to check out the manual. And if you're in the manual, let's say you are at the top of the manual, then you just press Ctrl+F and maybe just write BPM, and then you go through the manual, and pretty quickly it will lead you to the transport info thing that has a bunch of functions like get BPM. And you might ask yourself, well, where do I get the transport info object from? And if you look a little bit around in the in this API, then at some point you will notice that in the block data there is actually the transport info object. So that's where you get the BPM from. I was asked about the process sample method lately that is provided by plugin script, and this is one of the reasons why I wouldn't advise anyone to use the process sample method, because the process sample method doesn't have block data, and block data has just so many powerful things. Okay, so now that we have cleared that up, we can just modify our argument so that it takes a BPM. So now bool changed flag equals, and oh, of course we need an object of that. HDL, what was the name? Ah yeah, rate handler. So now we have a rate handler. Rate handler of the BPM and some parameters. Let's say 1/16. Let's just do that for testing now. So this would make a 1/16 rhythm, or maybe let's make it 3/16. So actually we don't really need to make this a variable. We can just put that directly into an if statement. If this was successful, only then we want to rewrite all this stuff, because why would we add a new value if it doesn't make a difference, right? Oh well, later we will have to put that in here. So we can just comment that out for now. And instead, what we're doing here is rate handler get rate. But we have to make a new function. I hope you already see the problem. Set delay in seconds is not true anymore, because this will get the samples in samples, the delay in samples. But that's pretty easy to solve. We just go into our class, and let's say set delay in samples, a new method that will just enable us to do this. Easy. Now we have to rewrite this. I just want to show you different ways to look at a delay, you know. That's why we wrote it with seconds first. So now we have it in samples, and it should make a 3/16 rhythm. But instead it crashes. Obviously, because 28 in main, double BPM. Why does it not like my BPM argument? I don't understand that now. Const int Why const? But this shouldn't be the problem. Set parameters double. Yeah, it wants a double. And it doesn't get a double? This is a double, right? I know that this is a double. It makes no sense. That can't be the problem. Or maybe I've written it wrongly. Do I still have the API open? No? Now let's open it again. Oh, that's annoying. This will slow down my video and make it look like half an hour or more. But whatever. Get BPM is const double. Okay, maybe the problem is that I didn't write const. Let me really quickly look how it looks in the other script. I also didn't write const there. So that can't be the problem. Okay, then let's just I see it. I did one thing differently. This expects doubles, but I gave it ints. Maybe that's the problem, even though usually that shouldn't be the problem. Okay, actually, at least now it says double double in here, but apparently that was not the problem. Main CSS, no matching signatures, rate hand. Oh my god. Obviously I forgot to mention the name of the method. That's pretty stupid, but I guess okay. Okay, now that this works, we can just move on and make our rate. And this is the rate now with the different possibilities. 64 steps, and feedback has an unlimited amount of steps. So now we can just put our input parameters directly in here. 0 and 1. Cool. And now we immediately have an error, and I think it wouldn't happen if I had this setting. Yeah, so why did it happen? Because at some point it tries to make a buffer access that is just going out of bounds. And I already know why. Because the thing is, when we set the delay, we just set it to whatever size we get here, and obviously if that is higher than our sample rate times 4, then it doesn't work. So what we need to do here is actually let's make a new function, and this time it doesn't need to be protected because we won't override this. We can call it avoid overflow or something, and it will get a value and the size. No, the size is part of the class anyway, so we don't need that. If d is Oh, actually, this is more like a clamp algorithm. Yeah. Is clamp written like this or like this? I don't know. I think like this. Private double clamp. If D is bigger or equals size, then D equals size. No, then return size -1. And this need to be double. Okay. Yeah. Okay, so now we can just say clamp on whatever we have here and here. Okay, so now this should work pretty fine. Let's see. No? Why? Oh, sure. And else return D, because nothing changed. Actually, we can make this more performant. If we write it the other way around, if D is smaller than size, then obviously we don't need to change anything. And else we return this. Yeah, that's better. Cool. Now the disadvantage of this implementation obviously is that this does not really resemble a delay of 64 bars, but but at least it doesn't let our stuff go out of bounds for now. So it's a little hacky solution, but it's fine for now. Okay, so now the last thing that we will add to this delay, you hear that it already sounds a lot like the one that I showed you in the beginning. So we just add the Retune Speed knob, and we let it range between yeah, so what do we do? 0 and oh, we will do this in seconds. More like around some seconds. And the lowest value will be 0.1 seconds, and the highest value will be 1 second, maybe. 2 seconds is a little bit too much. Really takes too long. So this would sound pretty nice, I guess. Yeah, this is the range now, and we have to add a new parameter for that. And obviously we don't need the delay parameter anymore. Do we even need the feedback one? Yeah, still we still need that. Okay. We need a new one, retune, with a default value at -1, so that it will be changed immediately if we implement any checks. And if retune is not the parameter, then retune is the parameter. And then delay L set retune. Let's just call it like this. Retune in seconds to be more descriptive. Now we have to implement this function, obviously. Notice how I always implement the functions in the feed forward delay, even though we already used the feedback delay. So everything will be usable in the feed forward delay as well. Yeah. Oops. My mouse is acting weird lately. So this is the retune speed in seconds. And now let me check my code because it has a little formula in it that I don't have in my mind. Yeah, okay. I am not sure if this is really making a retune speed that has exactly this time in seconds, but I think it works. Okay. First of all, we do this thing with the sample rate, but then we add the seconds to it. I have to let my cat in really quickly. She came home from a nice long adventure. She's very excited about it. Seems like we have to snuggle later. Okay, so now we have the retune speed in seconds. And I think that should be it. Let's try. Yeah, that sounds like it works very well. It changes the speed slowly on the higher values and fast on the low values, and something in between on the middle values, which sounds just like what we're trying to do. Yeah, so this is it. That's how you make a nice little stereo delay. Of course, this does not have ping pong delay functionality yet, so that's kind of sad. We have to do that later. But for now, this is pretty cool. And in the next video, I guess, I will discuss how this would look like in Juice. And then we will see the different benefits and disadvantages of doing this in PNS or in Juice. And I already thought this through a bit, so I can spoiler you that this will be very interesting, because there are actually things that are easier in C++ and Juice than in AngelScript, but there are also a lot of things that are just easier in PNS, and some other little aspects that we will discuss then. So stay tuned, and I hope you have a nice evening and fun with this little delay implementation. I will upload it to my PNS repository, as always, PNS Fundgrube and everything. So check that out and see ya.